I'll go through a very important lesson. Today's lesson is really going to be important, and it is important not because of examination. It is important in terms of examination, but more importantly, I think it is one of the three pillars of physics. We have actually gone through one of the pillars of physics. In case anyone asks you what is the difference between physics and chemistry or bio, yeah, I'm being recorded, so I have to be very careful what I say. So the main difference is that physics actually deals with motion, which we have already done, force and energy. So that really defines physics, and today we're going to do the force part of physics, right? A deeper understanding of what we mean by force. Let's begin with what we went through yesterday. Remember this case where we drop sand and then this moves at constant speed. The force, so we got sand over here. So I went through the dissonance, I showed you the dissonance where F equals to ma, and since the velocity is constant, but we also know that if you drop sand over here, you need a force to put at constant velocity. So when this is equal to 0, but we know that there must be a force, so how do we reconcile the two? So what Newton mentioned a couple of hundred years ago is that force is not equal to ma. That wasn't the original form. He mentioned that force is actually the rate of change of a component, what we call momentum, which is defined as mass times velocity. Yeah? So this is velocity, be very careful, it is velocity, it is not speed. And m is mass in kg. Now why is it that I have to emphasize that v is velocity? Because mv, which is momentum, is a what quantity? Scalar or vector? Vector quantity, exactly. So there will be many implications of this. That's why I want you to remember that mv, that v is actually velocity, not speed. Very important item, which I will leverage on in many topics. Okay? So how does this rate of change of mv leads on to this ma idea? Now I'm going to make some assumptions over here that you still remember this thing called the chain rule in mathematics. Do you remember? Yeah, so that if you remember, it might bring back some good memories that this is this plus this. Cool? Now what exactly is dv dt? Excellent. So equals to ma plus v dm dt. Now in secondary school, when you were in your IB years or your Sec 4 years, you don't deal with issues that has changed in mass. So naturally this will be equals to 0. So that's why F equals to ma. It's not wrong. It's just that it is under the assumption that the mass is constant. So you have to be aware. It is a possible question in exams. You have to know that F equals to ma, when is it true? It is true when the mass is constant. That's why dm dt is 0. But in this case, if you take a look at this, the v is constant. So the a is actually 0. Right? So therefore, F in this case is v dm dt. So in this example, the dm dt times v takes care of the force. It's the one that's accountable for the force. Okay? So for this case, it's ma that's 0. When you deal with a secondary school years cases, it is v dm dt that's equal to 0. And understand more how you can reconcile this scenario with the idea that it must be a force and that there's no acceleration. Why is there a force then? So it's actually because of the v dm dt. Okay? Cool. I'm not sure whether in your notes it's mentioned that m is equals to a constant for f equals to m to be true, but if it is not there, please make it clear in your notes. Very important thing. Now this is how we're going to deal with this definition of force. Let me just write this thing really big and high up there. It's ma plus v dm dt. So we're going to go back to deal with one more scenario over here. We're going to focus on the ma part, probably 2, and then we're going to deal with this portion, and then we're going to deal with this portion. So this is how we're going to deal with the second law of motion. Okay? So let's take a look at ma now. But before I go on to examples, any questions you'd like to ask? Any issues? Questions? Okay, if no question, then I will move on to the So we'll deal with 2 questions and one vertical, one horizontal. So let's start off with this one first, horizontal. It's always the easier one. 10 kg, 15 kg, so we are focusing on F equals to ma now. So we have 120 newtons, there is 5 newton and 10 newton force, frictional force. So first thing I like to do is to draw free body diagram and then find the acceleration and then find the tension in the string. Give it a try. Draw the free body diagram, find the acceleration. Using the free body diagram, draw up an equation so they can find A and T. Shouldn't take you more than 3-4 minutes. Free body diagram for the masses. I'm doing mental calculation today, so I might we'll check each other's answer. That's 73. You mean the answer for the last one? That was XG? What's that? Now the free body diagram should look like this. It's 15 kg. That should be tension. Some people have this issue of knowing what direction the force of string should be. Remember, string always pull. You never tie a string around someone and push the person, right? I mean, it never works. So unless it's a rod, then it works. Okay, if it is a string, it always pulls. So pull this way. And this is 10 newtons. So T minus 10 newton equals to 15A. And then for the other one, you've got 120 newtons. T over here, 10 kg, and you've got 5 newtons. So it will be 120 minus T minus 5 equals to 10A. So 2 equations, 2 unknowns, then you should be able to solve. The difficulty for some students, might have some difficulty for some students, is that they will have difficulty in having the idea to understand why is it that 120 doesn't apply here. Some students will draw the 120 newtons over here, which is wrong, because the 120 newtons doesn't act on the mass on the left. If you look carefully, it only acts on the mass on the right. Yeah? Ready for the second question? Second questions, I'll put it up into 2A, 2B of 2 different levels. Let's go for the easier level first. I'll leave it here. Leave the new question. Any questions before I move on? Any issues? Are you worried of being recorded or what? If I ask a stupid question, you will immortalize. Yes. Good question. Go ahead.
Can you do a diagram where you combine both masses together?
Can. Like what I mentioned yesterday, you can actually do the third case. You can actually combine the two masses and 25 kg. This is 120 newtons, and then you get 25 newtons. Yeah. By that, you can actually get an A direction. Can. But to get the tension, you have no choice but to consider the free body diagram. You cannot consider the two bodies as one body and get the tension. Yeah, so you have to split it up like that. And the reason why I force you to do the three body is more but you're correct, you can consider two bodies. Now let's try another question. This question, it catches some students, so just look carefully. Yeah? There are 2 stages to this question. This 15 kg object drops through a distance of 1.5 meters And after it hits the ground, this is before, and after it hits the ground, it caused an indentation of 5 centimeters. Now the question is, find the speed of object before hitting the ground. And the second point is find the force by ground on object. Give it a try. Be very careful of some things. It has been effective in tricking some students. I hope you can see that the question is can be broken down into kinematics and dynamics. Yeah? Kinematics and so you have to use kinematics and dynamics. Actually, there's another way of doing it. You can use energy, but we'll hold it for. There is another one. So the first part should be quite simple. It's v squared equals to u squared plus 2s, which is 2 times 9.81 times 1.5, which is equals to, can anyone just shout the number? 5.4. 5.4. Okay, fine. 5.42. Then how do you approach the second part? How do you find the force? What else do you need to find before you find the force? When it hits the ground, it undergoes, it's quite a long word starting with D, deceleration. So you have to find the deceleration during that phase. So how do you find the deceleration? You know your final speed, you know your initial speed, which is this one, and you know your distance traveled, which is 0.05, and you want to find your A. There's only one equation without C. So you can find your deceleration. And then the question is, after you find the deceleration, what do you do? By the way, has anyone solved that projectile problem that I gave? The one where it bounce? Anyone?
So I guess it's 3/4.
3/4 you mean? Yeah, it is correct. Your guess. Use your intuition. And what's the logic behind your intuition? That's the key. That's the key. You can solve it by math.
Yeah.
You can solve it by pure math. Just math it out. Can be done. Can anyone shout the number over here? It should be a rather big number. -294. Now, therefore, the mass, which this is 15 kg, so the force by the ground is equal to 15 kg times 294. I'll take the magnitude of this acceleration. Correct? Yeah. Alright, no? Correct? No? It's wrong. The question is, why is it wrong? This is exactly where students will make a mistake.
I thought, well, I don't know. I'm curious.
Don't make it.
But what I thought is like, it's like the energy of like half mv squared, and then take the weight of the thing and add it together and divide by 5 zeros. So it's like something equal.
Hang on, just took that out. So you mentioned half mv squared plus weight, but you're talking about energy plus weight. Force quantities. So you're considering a force equivalent of energy. You're actually half correct. I'll show you how your method can be correct. I'll show you later, yeah? So let me go back to the part where I talk about force first. Why is it that F equals to ma is wrong? Actually, F equals to ma is not wrong. It's because you consider half of the effect. So when the object hits the ground, what are the two forces acting on the ground? Acting on the object. Weight. Exactly. Normal contact force and weight. And this normal contact force is what we want to find, right? So do you agree that this is equal to ma? Therefore, what you missed out is this portion. Be very careful. The reason why students make this mistake is because the concept of net force must be really clear. Yeah? The net force equals to ma ideal must be very clear. And if you're clear about net force, then you consider this one. And that's why you see the free body diagram is very important. Yeah? The sensitivity actually helps you to clarify what force is. So even if the question doesn't need you to draw a free body diagram in your mind, you need to draw it. So once you get this, the question is correct. Now coming back to you, I mentioned that how do I use your approach and make it correct and get the same answer. And you find that the answer is actually quite similar. I'm going to show you this. Let's use energy approach, yeah? I'm skipping one topic, but since you mentioned it's a good moment to actually go through it. Can you see that total energy initial must be equal to total energy final plus work done against the ground? Yeah. Right. So initial energy is half mv squared, which is going to be equal to mgh plus force by ground times the distance it moved into the ground. Is there anything wrong over here? Be careful before you say yes. Is there anything wrong? It moved into the ground. Okay, actually there's an assumption that I make over here. Where do I take, which level do I take as a 0 PE level? Where do I take as a 0 PE level? The ground or the final position? The final position, exactly. So this one should have been positive or negative? Because if this is 0 PE, this object has moved into the ground, so it should have had negative E. So over here negative. And it makes a lot of difference if you don't have the negative. Yeah? So therefore you get your Fg is equal to half mv squared plus mgh divided by the d. Actually the h and the d is the same, so that's really the same. And you find that this is equal to half mv squared divided by d plus mg. And you'll find that these two, so either approach works if you do it correctly. Okay? Any questions?
Explain the equation again.
Which one? The energy or the energy one? Can. So basically what I'm using over here is just conservation energy. That the initial energy that it has at this point just before it touches the ground, and the final energy when it has when it reaches the final position. So any initial energy is equal to the final energy plus work done against like friction. So I'm taking the ground, the force by the ground as something like friction. A resistive force. Okay, now let's try another question. But before that, just 10 seconds. Anything that you'd like to clarify? Ask. Show off. Okay, okay. Now let's try another question that my personal favorite. So say for example, one day the lift breaks down and you want to somehow travel up to the 5th story using a lift. Die must go through a lift. So we construct a pulley and which allows you to pull yourself up. For some reason. You have the muscles to pull yourself up. Probably the only one who can do it over here is Derek. Yeah, mass of the man is equal to 60 kg. Mass of the lift is made of carbon fiber, so it's only 20 kg. And the acceleration, we have been dealing with acceleration upwards, so it's getting a bit boring. Let's say the acceleration, it wants to descend rather. 1.2 meters per second square. Okay, so he's nearing the top, so he's slowing down. Now, first thing, draw free body diagram for lift and for man. Part 2, find the tension in the string and find the normal contact force between the man and the string.
So just let it go so it will just fall on this.
Then you only be able to do it once. That's basically uncontrolled bungee jump. Anyone of you over here has done bungee jump before? Should give it a try. With your parents' consent, of course. Careful of the normal contact force that we went through last lesson. Be very mindful of the contact force. So how many forces acts on the man? 2. 2 or 3? 3. Okay. First of all, obviously is weight, right? What else? Normal force. Normal force being outwards, yeah. Tension. Tension on the person is up or down?
Down.
Down.
Then you resist it.
Now, if I exert a force downwards on the rope, the rope will exert a force upwards on me. Yeah, that's the the downward force is the force I exert on the rope. Yeah? Good. Lift, less contentious, obviously is tension here, weight of lift, and normal contact force. There you have the necessary diagram representation to write an equation already. But this time, do you take n plus WL minus T, or do you take T minus WL minus n? Remember what I said about direction where you take to be positive? Now that the acceleration is downwards, so you take, yes, correct, downwards minus outwards equals the mass of lift A, and this one is weight of man minus n minus T equals the mass of man A. That's it. You plug in the numbers, you get an answer. Very neat. It's a system. So if you follow this system, there's no way you can get it wrong. Unless you make very unexpected mistakes in